Imagine you're playing a video game, not just any video game, the most detailed, most immersive video game ever created. The kind where every blade of grass has its own physics, where the sky changes color based on the angle of a virtual sun, where the characters inside the game love, grieve, wonder, and believe completely that they are real. Now, here's the question that keeps certain physicists, philosophers, and mathematicians up at night. What if the universe, all of it, the stars, the atoms, the feeling of sunlight on your face, is something closer to a vast, incomprehensibly sophisticated computation? What if reality itself is code? I know it sounds like the setup to a science fiction novel, or maybe a late night philosophical rabbit hole you'd fall into after one too many cups of coffee. But here's the thing, this idea isn't fringe, it isn't dismissed. Some of the most brilliant minds in science and philosophy take it seriously, very seriously, and the deeper you look, the stranger and more fascinating it gets. Welcome to Cosmic Curiosity, the podcast where we chase the biggest, weirdest, most mind-expanding questions the universe has to offer. I am your host, and today, in our very first episode, we're diving headfirst into one of the most audacious ideas basically in the modern science and philosophy, which is the simulation hypothesis. So buckle up. Before we get into today's topic, let me take a moment to tell you about Cosmic Curiosity is all about, because if you're new here, I want you to know exactly what you've stumbled into. This podcast is for anyone who has ever looked up the night sky and felt that strange electric feeling, the mixture of wonder and vertigo, the sense that the universe is so much bigger, stranger, and more mysterious than everyday life lets us remember. Maybe you've wondered, what was there before the Big Bang? Is time travel possible? Is there life out there? And somewhere among those hundreds of billions of stars? And what even is consciousness? Why does anything exist at all? These aren't ideal questions. They sit at the beating heart of physics, cosmology, neuroscience, and philosophy. And the scientists working on them have uncovered answers that are, I promise you, stranger than anything you could dream of. So, here's what I want this podcast to be: a place where complexity becomes clarity, where the equations stay in the textbooks, but the wonder and the real meaning of those ideas comes right through your headphones and into your mind. And you don't need a physics degree to be here. You just need curiosity, and if you have that, you have everything. So let's begin. Setting up the big question: what is the simulation hypothesis? Let's start with the idea itself, laid out as simply as possible. The simulation hypothesis, sometimes called the simulation argument, is the proposal that we experience as physics reality might actually be computational simulation, like the Matrix, but without the leather and the sunglasses. The basic version goes something like this. Suppose that civilizations, intelligent species we might say, can survive long enough to develop extraordinary powerful computers. Computers so powerful they can simulate entire universes, complete with conscious beings who think and feel and experience things. If that's possible, then statistically, there should be far more simulated universes than real ones. And if that's true, then the odds are actually in favor of us being in a simulation right now. I know, take a breath. We will unpack all of that, but first let me ask you something a little more personal. Have you ever had a dream so vivid, so textured and real, and then when you woke up it took a few seconds to remember which word was which? The color of someone's voice, the weight of a street under your feet, the complete and challenging certainty that where you were was real. And our brains are very extraordinary. good at, like constructing reality. Every single thing you experience, the screen in front of you, the chair beneath you, the sound of my voice is a model. It's a reconstruction. Your brain takes raw signals from your senses and it builds a story. A vivid, seamless, convincing story that we call experience. So here's the question. The simulation hypothesis forces us to confront. If the brain can construct something that feels like absolute reality from electric signals, how would we know if those signals came from a simulated universe rather than a physical one? Short answer is we might not. This isn't new, so when we go to the quick history, the idea that reality might not be what it seems is ancient. Long before computers, long before physics, human beings sensed that something was strange about the world they inhabited. Plato, the ancient Greek philosopher around, I think, 380 BC, gave us one of history's most haunting thought experiments. He asked us to imagine prisoners chained in a cave. All their lives, they faced a wall. Behind them, outside the cave, the real world exists. But all they can see are shadows, which are projected onto the wall by objects passing in front of a fire. For the prisoners, the shadows are reality. They give them names. They study their patterns. They think they understand the world, but they are only ever seeing a projection, a representation, and never the thing itself. Plato wasn't talking about computers, of course. He was talking about knowledge, about how human perception might only ever give us a pale reflection of some deeper truths. But the resonance with modern ideas is striking. Then, in 1641, René Descartes, the French philosopher who gave us I think, therefore I am, took the skepticism even further. He asked, what if there is an evil demon, an infinitely powerful deceiver who has constructed an entire fake world designed to fool you? Everything you see, touch, feel, all of it fabricated, and how would you know? He couldn't find a satisfying answer, and the question has haunted Western philosophy ever since. Fast forward to the 20th century and the invention of computers. Suddenly, this wasn't just a philosophical puzzle. It became something engineers and physicists had to think about seriously, because now, for the first time, humanity had actually built machines that could simulate reality. Small simulations at first, weather patterns, fluid dynamics, particle collisions, but with each decade, the simulations got more intricate, more detailed, more real. There is some philosophers who formalized the idea. In 2003, a philosopher named Nick Bostrom, then at Oxford University, published a paper that changed the conversation forever. The paper was called, simply enough, Are You Living in a Computer Simulation? And while the title sounds like clickbait, the actual argument inside is rigorous and strange and deeply uncomfortable. Bostrom laid out what's known as the simulation argument, and it rates on three possibilities. He calls them trilemma, three options, and at least one of them must be true. When we go deep into these three options, option one, almost every civilization that reaches our level of technological sophistication goes extinct before it ever develops the ability to run universe-scale simulations. Something, it might be war, climate collapse, an asteroid, a technology they couldn't control, kills them all first. Always or nearly always. Option 2. Advanced civilizations could run such simulations, but they almost never choose to. Maybe they lose interest. Maybe they decide it's unethical. Maybe there's some universal reason why civilizations powerful enough to simulate reality decide not to. And option 3 is the one that keeps people awake. We are almost certainly living in a simulation right now. So here's Bostrom's logic. If advanced civilizations do survive, and if they do choose to run simulations of, their ancestors or conscious beings, then they wouldn't run just one simulation. They would run thousands, millions, maybe trillions, and a civilization with godlike computing power, exploring their own origins, testing scenarios, running models, they'd create an incomprehensible number of simulated minds. So count them up. How many real, original, base reality consciousness would there be, and how many simulated ones? If we think the ratio is even mildly lopsided, then statistically speaking, any given conscious mind, including yours, including mine, is far more likely to be simulated than real. Like I said, it keeps people awake. Now, you might be thinking, okay, but this is just philosophy. You can construct logical arguments about all kinds of things that aren't true, and what does the actual science say? Well, here's where it gets even more interesting. What does physics tell us? The first one is that the universe looks like it's made of information. One of the strangest discoveries of modern physics is that at its most fundamental level, the universe appears to be, digital. Not digital in a colloquial sense, like a photograph on your phone, but digital in the deep sense. There seems to be a minimum size of things, the smallest possible length, the smallest possible units of time, a kind of pixelation to reality. The smallest possible length is called the Planck length. It's named after the physicist Max Planck, and it's extraordinarily, almost laughably tiny. We're talking about, I don't know if I can say this, but almost but very, 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 very small meters, and that's 16 millions of a trillions of a trillions of a trillions of a meter, and a distance smaller than Planck lengths. Our current physics breaks down completely because space itself stopped making sense, which raises a very deeply strange question, to be honest. Why would there a minimum size to anything in a truly continuous universe? In a universe made of smooth, analog, infinitely divisible stuff, why is there a floor? Think about it. In a computer simulation, of course, there is always a resolution limit, right? A pixel size, a minimum units below which nothing is rendered. Because rendering it would cost too much computing power, and the universe having a minimum size is exactly what you'd expect if it were being run on some kind of computer. Now, to be clear, physicists don't think that the Planck length proves we're in a simulation, but they do think it's a clue, something to actually explain, and the simulation hypothesis is one framework that makes sense of it. There is another, which is called the quantum weirdness connection. It fits uncomfortably well. Quantum mechanics, the physics of the very small in another world, is famously bizarre. It's the science that describes how electrons, photons, and other particles behave, and one of its most very unsettling features is something called the measurement problem. In quantum mechanics, particles don't have definite properties like positions or velocity until they're observed or measured. So before measurement, a particle exists in what physicists called a superposition, a kind of blur of all possible states at once. It's not that we don't know where the electron is. It genuinely, physically isn't anywhere in particular. It's everywhere it could be all at once. And the moment it's measured, the moment it interacts with something that pins it down, it collapses into one definite state, one location, and maybe one velocity. Think about what this means. The universe at its most fundamental level only resolves itself when something is looking. In computing, there is a technique called lazy evaluation. It's It's a way of saving processing power. So you don't calculate something until it needs to be calculated, or you don't like basically render the back of a room until someone turns around. So don't compute the position of a particle until something measures it. The quantum behavior of particle looks to some physicists unsettlingly like lazy evaluation, like the universe is conserving computation by only rendering what's being observed. Again, this doesn't prove the simulation hypothesis, but it's at minimum a striking coincidence. The third thing is the digital nature of energy. There's one more piece of physics I want you to know about because it's very beautiful and strange in equal measure. Energy, which is light, heat, the radiation that comes off a star, doesn't come in smooth and continuous amounts. It comes in packets, discrete units called quanta. This was Max Planck's greatest insight, and it launched the entire field of quantum mechanics basically. The world at its base is quantized, which is chunked. It comes in indivisible units basically. And think about what that means for the simulation idea. In a digital system, a computer, a program, let's say, everything is ultimately discrete, right? Ones and zeros, indivisible bits. The idea that physical reality also seems to come in discrete, indivisible chunk feels to at least some physicists like something worth explaining. As the physicist James Gast, who works on supersymmetry at the University of Maryland, once described it, deep in the mathematical equations that describe fundamental physics, he and his colleagues found something they weren't looking for: error correcting codes. These are mathematical structures identical to the ones we deliberately write into computer software to make sure information doesn't get corrupted. He found error correcting codes in the equations of the universe. Gates himself is careful not to overstate what this means, but he's also honest about how strange it is. The universe apparently is self correcting, like software designed not to crash. So we have some counter arguments, which when we push back, now I'd be doing you a disservice if I only gave you the case of simulation hypotheses, because there are serious, smart objections and they matter. The first one is the computing power problem. The most immediate objection is also the most practical, which is simulating a universe is insanely hard. Think about what it would take. Not just to simulate planets and stars, but to simulate every particle, every pattern, every atom, every quantum interaction in the universe of hundreds of billions of galaxies, each containing hundreds of billions of stars, each of their own planets, atmospheres, molecules, electrons. The computational resource required would be staggering, to be honest, because unimaginably, almost incomprehensibly large. Proponents of the simulation hypothesis say maybe the simulators don't render everything at full resolution all the time. Maybe they use something like lazy evaluation we mentioned, only rendering what's being observed, cutting corners at scales too small to notice. Maybe they have access to physics and computing power we can't currently conceive of. That is possible, but it's a lot of maybes. And there's this another thing that's called the infinite regress problem. So on this, here is a philosophical wrinkle that I love. If we are in a simulation run by some advanced civilization, then what about them? Are they simulation too? Or are there simulators in a simulation and their simulators? You get a cascade of nested realities, each containing the next, each needing a layer above it to compute it, and there is no obvious place to stop. You need some base reality at the top of the chain, something that is truly fundamentally real and not simulated. But here is the uncomfortable thing. From inside our universe, we can't see the level above. We can't look up and spot the hardware we're running on, which means we can't distinguish ourselves from anyone else in the chain. We can't know if we are at the bottom, the top, or the middle. And some philosophers find this deeply troubling. Others find it strangely liberating. The third one is that it doesn't matter objection. This objection, it's not like a logical critic, but almost an emotional one. Even if we are in a simulation, so what? Your love for the people in your life is real to you. The taste of coffee in the morning, the grief of losing someone, the satisfaction of understanding something difficult, the beauty of a sky at the sunset. All of that is real in every way that matters. It is experienced, it is felt, and it kind of shapes you. Does it become less meaningful if it turns out to be a computational in nature? Many philosophers, and me, says no, because I think that's worth sitting with. I want to make sure you understand how seriously some very credible people take this idea, because it's easy to dismiss it as a fun thought experiment for stoners and science fiction writers. It's not. Elon Musk, whatever you think of him, is on record saying he believes the odds that we are in a base reality are 1 in billions. And Neil deGrasse Tyson, the astrophysicist and science communicator, has said he thinks that the simulation hypothesis is very likely true. Also, the cosmologist Max Tegmark at MIT has spent decades exploring the idea that the universe at its core is mathematical, that reality is literally made of mathematics, not merely described by it. His works basically sits in fascinating proximity to the simulation idea. And perhaps most striking at the 2016 Isaac Asimov Memorial Debate, a gathering of very serious scientists, the question was posed, are we living in a simulation? And when a poll was taken, most of the scientists in the room either thought it was possible or probable. This isn't a fringe idea, it's a live question, one that sits very uncomfortably at the boundary between physics and philosophy, science and metaphysics, the known and the almost certainly unknowable. And here is the wildest wrinkle of all. If someone wanted to prove we were in a simulation, how would they do it? And what would they look for? Actually, some physicists proposed experimental tests. One idea is to look for tiny systematic errors in the fabric of space-time, like glitches. If the universe is being computed, it's possible that the computation isn't perfect at every scale. There might be slight inconsistencies in the directions that high-energy particles travel. It might be tiny deviations that would only be visible at extreme energies, which kind of like hinting that the underlying grid of simulation. Experiments are actually being designed to look for exactly this, and we might, in other words, be able to look for the pixels. So why this idea changes everything? Let's step back, and why does any of this matter? Even if we can't prove it, even if we never could, why should we care about the simulation hypothesis? I think there are a few answers, and they're all genuinely important. First, it forces us to examine the foundations of our knowledge. When Descartes asked his evil demon question, the real point wasn't to make people paranoid, it was to ask, what do we actually know for certain? What can we trust? Science at its core is an attempt to answer that question honestly. The simulation hypothesis is a modern version of the same ancient challenge, and wrestling with it makes us sharper. It makes us think. It changes how we think about consciousness. If a simulation can contain beings who experience reality, who feel, think, love, suffer, then experience doesn't depend on being made of neurons or atoms in a particular physical arrangement. It depends on the pattern. It depends on the information. This is very profound for how we think about minds, about what consciousness actually is, and about whether artificial intelligence could ever be truly sentient. Um, Third, if it's true, and let me be clear, that is a very big if, then it opens up extraordinary possibilities. It means that reality might be malleable in ways we can barely imagine, that the rules of physics might not be fundamentally constant, but design choices, that whoever is running the simulation might be able to change things. And fourth, and this is one that stays with me most of the time, it is a reminder of how profound and improbable our situation already is. We are conscious beings in a universe almost 15 billion years old, according to science, made of atoms forged in dying stars, capable of asking questions about our own existence, whether we're real in some ultimate metaphysical sense or running on someone else's hardware that remains extraordinary. The more I look into the simulation hypotheses, is the more I understood about God's existence. Because science might explain a lot of things, and we might prove a lot of things by experiments, but this isn't something that we can actually do, because as I said, there are a lot of maybes and there is a big if. So I want to close with something that I think sits at the heart of everything we talked about today. Here we are, wherever here actually is, whether you find the simulation hypothesis thrilling or unsettling or just plain ridiculous. What I hope you take away from today is the feeling that reality is genuinely strange, strangely deep, and that the universe we live in is not the simple, mechanical, well understood place we sometimes pretend it is. Quantum particles that don't have definite properties until they're observed. A universe with a minimum size. Energy that comes in discrete packets. Mathematical structures and the laws of physics that look like error correcting code. A probability argument that suggests a simulated mind should vastly outnumber real ones. These aren't the things on the fringe. There are things in the textbooks, in the peer-reviewed papers, in the conversations that physicists have when they let their guards down. The universe is weirder than we know. And I believe we have barely begun to find out how weird. Here's the question I want to live with you today. That's a rhetorical question, an actual question that I would like you to sit with. If you found out tomorrow that you were living in a simulation, what would change? Would you feel differently about the people you love, about the choices you've made, about what you want to do with your time here? Maybe nothing would change, maybe everything would, but either way, the asking is worth it. That's it, the first episode for Cosmic Curiosity. Thank you so much for being here, for lending me your attention and your curiosity. It genuinely means everything. In the coming episodes, we're going to explore some of the most breathtaking ideas in science: the nature of time, the possibility of parallel universe, the strange relationship between consciousness and physics, what happened before the Big Bang, and so much more. If this episode sparked something for you, if it made you think or wonder or want to look something up at 2 in the morning, that is exactly the goal. Share it with someone who might feel the same way, because the best part of wonder is sharing it. Until next time, keep looking up, keep asking, and remember, the universe is far stranger and far more beautiful than it has any reason to be.